Hello everyone, I am Punyakeerthi BL. Welcome to my Python for Generative AI learning series. In this series, we are focusing on Python basics that will help us to build a strong foundation for implementing generative AI concepts. So let's dive in and start today's session. So today's topic is global versus local variables in Python. Understanding scopes with easy examples. Let's start with some example introduction. So when writing Python programs, variables can exist in different scopes. Some are accessible everywhere, while others only exist inside specific blocks or functions. Understanding how these scopes work is crucial because it affects how your variables behave and whether your program gives the results you expect. In this lesson, we will explore the difference between global and local scopes, look at a common pitfall many beginners face, and learn how to correctly modify global variables from inside a function. We will also talk about shadowing, another common mistake that can lead to confusing bugs. Let's start with global and local variables. Let's start with this example and understand what it is doing. So, I have a function, let accuracy is equal to 0.5, where we specify global variable. Then we have a update accuracy function. Inside also again we specified accuracy variable that is of value 0.9, and we are printing updated accuracy inside the function, that is accuracy. Then we are calling updated accuracy function. Then we are printing accuracy outside function with accuracy value. Let's see the output. Here the accuracy, updated accuracy inside the function is 0.9 and accuracy outside the function is 0.85. So let's understand what is this. So the variable accuracy defined outside the function belongs to the global scope. This means it can be accessed anywhere in the file. Inside the function update accuracy function, we create another variable with the same name, accuracy. However, this is new accuracy is local to that function. It exists only while the function runs. When you print accuracy inside the function, it shows 0.9, but the global accuracy outside the function remains 0.85. So this behavior often surprises beginners because even though we assigned a new value inside the function, the global variable didn't change. So how to modify a global variable? Let's understand this. What if you actually want to update the global variable from inside a function? We can do that using the global keyword. Let's understand same example, but how we can use global keyword to modify the global variable. So accuracy defined outside the all functions, and inside the update accuracy, I'm specifying global keyword accuracy. Then accuracy I am changing. Now we are telling the Python to use the global variable and we are updating. Now what I will do, accuracy before update, what it will do, what will it will print. Then after that, so before it is 0.85, but updated accuracy inside function 0.9. Now accuracy outside the function also updated. Using global keyword, we can tell the Python to use global variable. Let's understand. The line global accuracy tells Python that we are referring to the global variable named accuracy, not creating a new local one. Now when we assign accuracy 0.9, it actually changes the global variable. After running the function, the new value is reflected everywhere. So let's go with important note. Important note. While the global keyword can be helpful, overusing it is not a good practice. If too many functions modify global variables directly, your code can become hard to understand and debug because it's unclear where and when values are changing. A better approach is often to return a value from the function and assign it outside like this. So let's see what function is returning what value and how it is helpful when we are going for a debug. So here I defined the accuracy variable with value 0.85 outside all the function. That's why it is a local variable. Then we have update accuracy function. What it will do, it will return whatever value we passed with 0.5. So what I will do, accuracy is equal to update accuracy. I am giving accuracy as the value. So for the accuracy value, it will add 0.05 and we will get the new accuracy variable. So when I print, new accuracy becomes 0.9, before it was 0.85. This is the better approach to handle the global variables. This method is cleaner, and avoids side effects. Let's go with next topic, avoiding variable shadowing. Another important concept related to variable naming is shadowing. Shadowing happens when you give a variable or function the same name as built-in Python function. This hides or shadows the original built-in, leading to confusing behavior. Let's see. We have a function called sum. We have a function called sum of 1 comma 2 comma 3. So when I run, it is printing 6. But now what I will do, I will define my own function definition sum, which is not inbuilt, it is defining, and I am passing. When you pass the values, it should return the values. When we are calling function sum, now it is printing 1 2 3, not the sum, because sum function is override. What happens, let's understand. Python already has a built-in function named sum that adds up numbers in a list. But when we define our own function with the same name, our version replaces the built-in one. That is happened here. Sum already it is there. I tried to redefine some function with the sum, and I'm trying to call that one. So it is not giving the sum of the values which we are passed, but it is returning values which we are or whatever we passed as it is replying or returning. Now if you try to use the sum to add numbers, it won't work as expected. That is what happens. Okay, now the issue we come to know. Now how to fix this? It just prints the list instead of adding numbers, right? So how to fix it? Simply use a different name for your variable or function. So what I am going to do, let's see. Here only I will do like this. Define some values. This is the function which is I defined. I'm passing the values and returning sum of that values. So I'm calling some values with these values 1 2 3. So when I get, so it is printing 1 2 3 because already inside that it is this one. So I will restart the session, and again we can try, then we can see what happens. Now we are getting the 6 value. Why? Because when you override that, and in that session that becomes override, and we are not able to call that function again and again. So now I restarted the session. When we define this one, it is some values using some function and getting the return value, some of the values as it is. So now the code works perfectly because we are not interfering with Python's built-in sum function. What is the best practice is always check that your variable or function names don't conflict with Python's built-in names like sum, list, dict, max, min, input, etc. So key takeaways. Global variables are defined outside functions and accessible everywhere. Local variables exist only inside the function where they are defined. Assigning a value to a variable inside a function creates a new local variable by default. Use the global keyword if you want to modify a global variable inside a function, but use it sparingly. Avoid shadowing built-in function names. It can cause unexpected errors. Let's recap. In this lesson, we learned the difference between global and local scopes. Why a variable inside a function does not automatically change the global one. How to modify a global variable using the global keyword. What variable shadowing means and how to avoid it. By keeping your variables properly scoped and named, your code will be cleaner, safer, and easier to maintain. So, thank you for watching today's session. This is part of Python for Generative AI learning series. I am Punyakeerthi BL. If you feel this helpful, please subscribe to my channel for more videos. Also, feel free to connect with me on LinkedIn. The link is in description. See you in the next session. Thank you very much.